Hey there, so today we're going to take a try at some chip-off data recovery on a Samsung Note 4. The Note 4 uses a pretty unique BGA, what is it, BGA529 is the socket layout. So I just got this in the mail, bought it on Amazon. We're going to get the chip off, and hopefully this wasn't updated to Android 6.0 or newer with native data encryption, and hopefully we can get something off of this phone, because all other attempts to recover data by just getting it to power back up have failed up to this point. So let's take a look. Here is our Note 4 motherboard. This is a storage drive, so we're gonna trim off all of this metal plating around it, all this support grid here, so we can get underneath the chip and get it removed from the board. So while the Note 4 is a unique design storage drive, it's not the PCIe. It still uses a Emmc type of storage, so it is readable just through USB or as a memory card. So as long as the actual operating system didn't force encryption on it, there will hopefully be some legible data on this chip to recover for this guy. And it's not PCIe for the newer ones. I think it's called UFS is the name of the data architecture on them. Similar to a older iPhone NAND and a newer iPhone PCIe storage drive, though it does take a different type of reader to access the data, and those readers can be expensive. Not can be, they are expensive. For me, it's unlikely to remove it without causing some pretty significant damage to the board where it attaches. So I tend to treat chip-off data recovery as kind of a last resort, especially if it wasn't a roll of the dice as to whether their Android operating system was fully updated and the data encrypted. If that wasn't such a roll of the dice, it would be worth doing straight to chip off every time. But if the data on here is encrypted, we're going to be pretty much wasting our time anyway at this point. So in that case, it's definitely better to get this device to just power up where you can access it normally. Even if you gotta, if they come in and it's all smashed to bits and you gotta buy a screen, that's the cost of doing business as far as data recovery. Okay, so the preheater is on. The idea being, especially on an underfilled chip that has data on it, I don't want to put so much heat that we destroy the chip. I also want to, if at all possible, preserve the BGA mounting surface on the board underneath the chip. If for some reason later on down the road I decide to put this back on and give it one more shot. And there we go. So I'm using one of these kind of specialized, specially designed at least, BGA knives. Just a super thin, much thinner than a normal X-Acto knife. Pre-cut piece of metal that fits in an X-Acto handle. You can get these all over the place. The idea here is it's going to be thin enough to slide under this chip and eat away some of this underfill, kind of push it away and get in between those solder balls. God, this stuff stinks. Definitely moving solder. Okay, and there we have it. Oh, it stinks so bad. And we pulled quite a few pads. If you look in this area in particular, you can see the bottom end of the pads there. Hopefully these are going to be mostly NC, not connected pads. This is a two-part chip, isn't it? And I bet we only need the top half, because the bottom is probably the CPU. Split it. Let's split it. That's going to be a challenge, isn't it? Wow. Wow. Okay. And there we have it. So put that back there. And I think we can pretty officially say this this phone is not coming back to us. It's not going to come back on, so we're pretty much well past the point of no return. We really want to recover any data available on here. So, next step is going to be to if it fits at least a little bit in one of our iPhone socket cleaners. Really don't want it hanging off the edge anywhere. But, no, not really. Okay, we'll do it the old-fashioned way. Okay, yeah, there's actually a good bit of glue still left in this area. That's really going to need to come up. This is missing, but it appears to be not connected to anything. So it should be okay on that angle. I'm going to really gently, really carefully remove the rest of that glue. So I got my temperature turned down quite a bit. We were removing this around 900 F. I've got it down to about 400 right now. Really just to loosen up this underfill adhesive. And there's still some solder on there. Maybe if we just gently wick it again, right out. Okay, that is a clean chip. Alright, so up next, let's figure out what this is supposed to look like. Alright, so we've got an arrow. So this arrow is going to indicate where your A1 pin goes. And it does appear that we've got some contact points all over the place here. So this is going to sit in here like so. Alright. Snap it down. Now let's plug it into the computer. let's do this. I'm going to open up one thing at a time. All right, let's go. Let's get this hooked up to the computer. And maybe press the power button. Yeah, there we go. Okay. And now, let's open up RStudio. Check this out. This just shows up as USB drive. Oh dear. Oh dear. Okay, you need to format the disk in drive KLM. We don't want to do any formatting. Okay. Cancel. Okay. Cancel. 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 Boy, oh boy, we're up to drive X and Y. We don't want to format any disks. Hopefully this stops at some point and we can get it open with RStudio. Okay. Empty space. Ooh, here we go. Eric SD, Emmc. So we've got a total. Oops, nope, 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 nope. Alright, we've got some data. Let's see if it makes any sense. The best way to do this is going to be what do we want to do? Let's do scan. And we'll save the file. Continue. It's RStudio. We're going to name this. So this is, I don't really know exactly how this works, honestly. So we're going to name it Note 4. We'll do a simple scan and see what we can find. This is going to run for a while. But the reader does seem to be working. It's got a shitload of kind of useless partitions there, but then we've got several. I'm thinking this one's probably system, this one's probably your recovery partition. These are just, who knows, and this is probably the one that we're after. So I think if we have to pick one, we'll start with this for data recovery. And as long as the data makes sense, we might have a op success. Okay, now about 3 hours later, that process has completed. So the first thing we did was we scanned the data sector by sector, and then I went ahead and copied an image of this chip over to the computer. So if something happens to the chip itself, we can still access that image. Now let's do the fun part. So we've got a whole lot of stuff in here. Let's see what's available. If there's anything on here that presents itself as decipherable data. I'm just going to hit this Open Drive Files button. Oh boy, this might take a while. Well, it definitely sees files and folders. Okay, and 6 hours later, after several steps of deciphering data, we were able to recover somewhere in the neighborhood of 36 gigs worth of data. Now, a lot of this is system stuff. A lot of this is not going to be relevant to the user experience, but we do have plenty of user data to deliver back. So in that regard, we'll call it a huge success. So that's it. Thanks for watching. Leave a comment if you want to know more. Thanks.